Imagine a world where everything is reversed. A place where the familiar rules of physics and reality are turned on their head. Up is down, left is right. The compass points south when it should point north, and the sun rises in the west. Instead of matter, there's antimatter. This isn't just a concept from science fiction. It's a real phenomenon that scientists study. It sounds like science fiction, but it might be closer to reality than we think. Antimatter could hold the key to understanding the very fabric of our universe. Antimatter is real, and it has the potential to unlock some of the universe's greatest mysteries. What is antimatter? It's a substance that behaves like a mirror image of the matter we know. It's the mirror image of matter, the stuff that makes up you, me, and everything we see around us. Imagine looking at yourself in a mirror. Antimatter is like that reflection, but in particle form. For every particle of matter there exists an antiparticle with the same mass but opposite charge. These antiparticles are the counterparts to the protons, neutrons, and electrons that make up our world. When matter and antimatter meet, they annihilate each other in a burst of pure energy. This reaction releases an enormous amount of energy, far more than any chemical reaction. This explosive reaction is what makes antimatter so fascinating and potentially dangerous. Scientists are intrigued by its potential for both destruction and discovery. It's also why we don't encounter antimatter very often here on Earth. In our everyday lives, antimatter is incredibly rare and difficult to produce. Our universe, for reasons we don't fully understand, seems to be dominated by matter. The imbalance between matter and antimatter is one of the greatest mysteries in cosmology. Researchers around the world are working tirelessly to uncover the secrets of antimatter. Understanding it could revolutionize our knowledge of the universe and lead to groundbreaking technological advancements. From potential energy sources to new forms of propulsion for space travel, the possibilities are endless. The study of antimatter is not just about understanding the universe, it's about shaping the future. As we continue to explore this mirror universe, we may find answers to questions we haven't even thought to ask yet. The journey into the world of antimatter is just beginning. Every atom has an antimatter counterpart. For example, the antiparticle of the negatively charged electron is the positively charged positron. Similarly, the antiproton is the antimatter twin of the positively charged proton. These antiparticles are not just theoretical constructs. Scientists have created antimatter in laboratories, albeit in minuscule amounts. The first antimatter particle, the positron, was discovered in 1932 by Carl Anderson. This discovery shook the foundations of physics and opened a new chapter in our understanding of the universe. But creating and storing antimatter is incredibly difficult and expensive. Antimatter annihilates instantly upon contact with matter, making it a challenge to contain and study. The existence of antimatter was first predicted by physicist Paul Dirac in 1928. This groundbreaking idea emerged from his efforts to merge the principles of quantum mechanics with Einstein's special relativity, a task that had perplexed many of his contemporaries. Dirac's equations, which sought to reconcile these two pillars of modern physics, pointed to the existence of a negative energy counterpart to the electron. This theoretical particle, which we now know as the positron, was a radical concept at the time. Initially, Dirac's prediction was met with skepticism. Many physicists found it hard to believe that such a particle could exist. However, the discovery of the positron in the early 1930s by Carl Anderson provided the experimental confirmation that Dirac's theory needed. This discovery was a monumental moment in the history of physics. The confirmation of the positron was a triumph for theoretical physics, and ushered in a new era of exploration into the fundamental nature of reality. Scientists around the world celebrated this breakthrough, which opened up new avenues of research and deepened our understanding of the universe. Dirac's work opened up a Pandora's box of questions. If antimatter exists, where is it? This question has puzzled scientists for decades and continues to be a major area of research in modern physics. If antimatter exists, where is it? Why do we not see it in our everyday lives? These questions have led to numerous experiments and observations both on Earth and in space to detect and understand antimatter. Why is our universe seemingly dominated by matter? This is one of the biggest mysteries in cosmology. The asymmetry between matter and antimatter in the universe is a topic of intense study and debate among physicists. Could there be entire galaxies or even universes made entirely of antimatter? This tantalizing possibility has inspired countless theories and speculations. The search for antimatter continues, driving us to explore the farthest reaches of space and the deepest questions about the nature of our universe. The Big Bang Theory, our best model for the origin of the universe, suggests that matter and antimatter should have been created in equal amounts. This monumental event, occurring approximately 13.8 billion years ago, set the stage for everything we observe today. According to the theory, the universe began as an incredibly hot and dense point, which then expanded and cooled, allowing particles to form. However, this is clearly not the case in the observable universe. When we look around, we see a universe dominated by matter with very little antimatter to be found. This discrepancy is puzzling because if matter and antimatter were created in equal amounts, they should have annihilated each other completely, leaving behind a universe filled with just energy. This asymmetry, known as the baryon asymmetry problem, remains one of the biggest unsolved mysteries in cosmology. Scientists have been grappling with this issue for decades, trying to understand why there is so much more matter than antimatter. The answer to this question could reveal fundamental truths about the nature of our universe. Some theories suggest that there might be subtle differences in the behavior of matter and antimatter that gave matter the upper hand in the early universe. These differences could have caused a slight imbalance, allowing matter to survive while antimatter was annihilated. Experiments in particle accelerators are ongoing to detect these tiny differences. Others propose the existence of exotic particles or forces that we haven't yet discovered. These hypothetical particles could have interacted with matter and antimatter in ways that we don't yet understand, tipping the balance in favor of matter. The search for these particles is a major focus of modern physics. Solving this puzzle is crucial for understanding why we are here and what the ultimate fate of the universe might be. If we can uncover the reasons behind the matter-antimatter imbalance, we could gain insights into the fundamental laws that govern our universe and perhaps even predict its future. The quest to solve this cosmic mystery continues to drive scientific inquiry and exploration. Section 5. The ultimate energy source. Antimatter has the potential to be the most efficient energy source ever discovered. A tiny amount of antimatter, when brought into contact with matter, can release tremendous amounts of energy, far exceeding that of even nuclear reactions. Imagine powering entire cities with just a few grams of antimatter. Spaceships could travel at incredible speeds, reaching distant stars within human lifetimes. While these possibilities are still firmly in the realm of science fiction, the potential of antimatter is undeniable. However, harnessing this power safely and efficiently remains a formidable challenge. The cost of producing and storing antimatter is currently astronomical, making it impractical for any near-term applications. Section 6. Antimatter spaceships and beyond. Science fiction writers have long been captivated by the possibilities of antimatter. From the warp drive of the Starship Enterprise to the devastating antimatter weapons of countless science fiction universes, antimatter has fueled our imaginations for decades. While some of these concepts might remain forever in the realm of fiction, others might be closer to reality than we think. Antimatter propulsion, for example, is an active area of research, albeit in its very early stages. The challenges of containing and manipulating antimatter on a scale required for practical applications are immense, but the potential rewards are too great to ignore. Section 7. A portal to other realms. Some physicists have proposed even more exotic possibilities for antimatter, suggesting that it could hold the key to unlocking the secrets of parallel universes, or even provide evidence for higher dimensions. Could antimatter be a bridge to a hidden reality, a mirror universe where everything is reversed? Could it be the missing link in our understanding of dark matter, the mysterious substance that makes up the majority of the universe's mass? These questions remain purely speculative at this point, but the very act of asking them pushes the boundaries of our scientific understanding and inspires us to explore the unknown. Section 8. The mystery deepens. The more we learn about antimatter, the more we realize how much we don't know. It is a tantalizing enigma, a cosmic mirror reflecting back at us the profound mysteries of the universe. Why is there so little antimatter in the observable universe? What secrets does it hold about the fundamental nature of reality? Could it one day provide us with a source of clean, limitless energy? The quest to understand antimatter is a journey into the heart of existence itself, a journey that promises to challenge our assumptions and redefine our place in the cosmos. Section 9, A Universe of Questions. Antimatter is a paradox, a whisper of a universe that might have been. It is a testament to the power of human curiosity and our relentless pursuit of knowledge. As we continue to probe the mysteries of antimatter, we are confronted with fundamental questions about the nature of reality itself. What if we could unlock the full potential of antimatter? What wonders might we discover, and what new mysteries might it reveal? The universe is full of surprises, and the answers, if we dare to seek them, might be more astounding than we can possibly imagine. What do you think lies hidden within the heart of antimatter?